Here we want to figure out how to get the derivative formulas for the inverse trig functions. So suppose y is equal to inverse sine of x, and I want to find the derivative, so dy dx. So what we're going to do is we're going to switch it around. So think of the original sine function and then use implicit differentiation. So y equals inverse sine of x is the same as saying x is equal to sine of y, and then now use implicit differentiation. So we take the derivative with respect to x of the whole thing, of the whole equation. So the derivative of x is equal to 1. Derivative of sine is cosine. Then we have to use the chain rule because we're applying implicit differentiation. So the derivative of y with respect to x would be dy dx. And then now solving for dy dx, get 1 over cosine y. And so now we want to write everything in terms of x because we're differentiating with respect to x. So we use the trig identity, sine squared y plus cosine squared y is equal to 1. And then solving for cosine of y, you get dy dx is equal to 1 over the square root of 1 minus sine squared y. The sine of y is equal to x. So we can plug it back into here. So dy dx is equal to 1 over the square root of 1 minus x squared. And so for the derivatives, so here we've derived the derivative formula for the inverse sine. So we've shown that the derivative of inverse sine of x is equal to 1 over the square root of 1 minus x squared. So I'm going to skip the derivation of the other inverse trig functions, but it follows along exactly the same idea, right? To use implicit differentiation and work out the implicit differentiation, and then use some kind of substitution to get everything in terms of x. So the other derivatives are the derivative of tangent, inverse tangent, is equal to 1 over 1 plus x squared. Derivative of inverse secant is equal to 1 over the absolute value of x times the square root of x squared minus 1. And these are the three more important of the inverse trig functions. But I'll just write down the other ones to be complete. root of inverse cosine is minus 1 over square root of 1 minus x squared. Here, x is between minus 1 and 1. Inverse cotangent is minus 1 over 1 plus x squared. Here x can be anything. And derivative of inverse cosecant is equal to minus 1 over the value of x, square root of x squared minus 1. Here, as the value of x has to be bigger than 1. But again, these are the three most important ones. So these are the formulas that you should memorize. Okay, so let's look at some examples of computing derivatives involving inverse trig functions. Okay, so let's try to compute these three derivatives. So let's look at the first one. So this function is x times inverse sine of x. So because it's the product of two functions, I need to use the product rule. Derivative of x is 1. So the product rule says you take the derivative of each factor one at a time. So derivative of x is 1. It'll be 1 times, and then the second part stays the same. So 1 times inverse sine of x. And then plus, so here the x stays the same. And then derivative of inverse sine of x, which we had before, was 1 over the square root of 1 minus x squared. And so this is equal to inverse sine of x plus x over square root of 1 minus x squared. Okay, so now let's look at the second example. So we want to compute the derivative of inverse sine of ln of x. And so here, because it's a composition of functions, we apply the chain rule. So the derivative of the outside function, which is inverse sine, is 1 over the square root of 1 minus x squared. Instead of putting x, because it's a composition of function, I need to plug the inside function in. So that's the derivative of the outside function, leaving the inside function. And times the derivative of the inside function, derivative of ln of x is 1 over x. And so simplifying this, this is 1 over x times the square root 1 minus ln of x squared. Finally, in the last example, we have the inverse tangent of 1 over x. And so again, it requires the chain rule. Derivative of the outside function, inverse tangent, is 1 over 1 plus x squared. But again, instead of x, because it's the chain rule, we leave this part blank and we plug in the inside function. So 1 over x times the derivative of the outside function. So the derivative of 1 over x is minus 1 over x squared. So this is equal to 1 minus 1 over x squared times 1 plus 1 over x squared. And so simplifying this, is equal to minus 1 over x squared plus 1.